Today we are with another problem in electrostatics. The question is we can have three charges like this. That is, consider the charges Q, Q and minus Q. These two positive and this is negative. Placed at the vertices of an equilateral triangle as shown in the figure. Find the force on each charge. So there are three charges arranged like this. Each side having a length L. L is the length of each side. L here also L. Okay, this is also L. So we have three charges here, positive Q, here positive Q, here is negative Q. What's our aim? We need to find the force on each charge because these are three charges. Each charge will experience a force due to the other two charges. We need to find the force on each charge. Means we need to find the force on the charge at A, net force. We need to find the net force on the charge at B and net force on the charge at C. So first we will see net force on the charge at A. This we can see. Okay. So we can see from the figure this negative charge, this positive charge. For this charge will attract in that direction. Okay. So I can just note down the direction. So the attractive force I will give FAC. Okay, FAC in this direction. So this charge, since it is negative, this charge will be attracted towards it. Now what about this charge? This is positive. This is also positive. So this charge will try to repel. So which is a directional repulsion? This will be a directional repulsion. I can give a symbol F AB. Okay. So FAB and FAC. These are the two forces. What about the magnitude of these two forces? The magnitude will be same because the distance will be same, charge also same. Only one direction, means direction force will be different, but force will have same magnitude. I can say FAC. It will be equal to FAB. Both will be same. What is the value? K into, what is K? K is 1 by 4 pi epsilon 0. K into product of the charges. See, it will be Q square by distance square. Distance square is L square. L into L, L square. So we have got these two forces acting on this charge. Now we need to find the resultant. Now how will you find resultant? By parallelogram law we can find the resultant. Okay. So this will be the resultant. When you construct parallelogram, diagonal will be resultant. We can give the name for the resultant FA. Okay, FA. What is the angle between these two vectors? Between FAC and FAB. So since an equilateral triangle, we know that this angle is 60 degree. What will be the remaining angle? It will be 120. Okay. So angle between these two vectors is 120 degree. So we will find net force FA is equal to, we can say FAC square. We'll write FA square is equal to FAC square plus FAB square plus 2 into FAC into FAB into cos 120. This will be our equation. Okay, cos 120. Now we'll make the calculation. FAC and FAB having same value. Okay, both are same. So we can write like this. This to add, when we add this together, we can write FAC square plus FAC square plus FAC. This is also FAC because magnitude is same. 2 FAC and FAC will be FAC square. What is cos 120? It will be minus 1 by 2. So these two cancels. So 2 FAC square, 2 FAC square. These two adding, then minus FAC square. Okay, so what's the resulting value? You will get FAC square. So what is FA? This is square. So what is FA? FA is equal to square root of this, that is FAC. What is the value? FAC? FAC is equal to K into, what is the value? K into Q square by L square. So we have got one value. So we have got the net force on the charge at A. Okay, so that's over. Now we'll consider this charge. As we have seen here, we can see that this charge is pulled towards this because it is negative. This charge is pulled away, pushed to this direction because this positive, it will push in the opposite direction. Okay, which are the names of the forces, we can write this is FBC, sorry, FBA, and this we can give the symbol FBC. And what will be the resultant of these two? By parallelogram law, this will be the resultant force. Okay, and resultant we can give another name FB. Now this will be similar to this because both having same equation. Now we'll write what is FBA. What is FBA here? FBA is equal to FBA and FBC will have same magnitude. FBC also, why same magnitude? Because distance between the charges is same, here also same, charge also having same magnitude. And what will be the magnitude? It will be equal to K into Q square by L square. Q square by L square. The same equation we are getting here also. The resultant also will be having same value because charges are same, forces are in same magnitude. Okay. So how will you find the resultant? We will find the resultant of these two. As we have done in the previous case, we'll get same answer. We can find the resultant FB. It will be equal to either FBA or FBC. So it will be equal to K into Q square by L square. So the same process that we have done here, we can apply here also. So resulting the same equation. Both will be same in value. Okay, because here also we can see that angle between these two vectors is 120 degree, this 120 degree, magnitudes are same as that of this, so the resultant also will be the same. Now we have a third charge here. Okay, we need to find net force on the charge at C. So this charge is attracted towards A because it is positive. It will experience an attractive force downward. And we can give the magnitude of the force, it is Fca. What about this? This also will attract in this direction. This is negative, feel an attractive force in this direction. I can give the symbol Fcb. Okay. Now what about the magnitude of Fca and Fcb? So we will see Fca and Fcb. This magnitude will be same between these two forces, between these two charges. Force will be same. We can say Fca, okay, is equal to Fcb. What is the value? K into Q square by L square. No problem. Now we need to find the resultant. What is the angle between these two vectors? It will be 60 degree. Okay, since it is right and since it is equilateral triangle. What is the resultant force? See, resultant force Fc is equal to Fc square is equal to Fca square plus Fcb square plus 2 Fca Fcb cos 60. Cos 60 is there. Okay. These two having same magnitude because Fca is equal to Fcb. So as we had done in the previous cases, what we can do? We can take this 2 times 2 Fca square plus 2 into this also Fca and Fca. Because Fca and Fcb have same magnitude, we can write 2 Fca square. When you multiply these two, you have Fca square cos 60. What is the value of cos 60? Okay, cos 60 is equal to 1 by 2. So we'll see it is equal to 1 by 2. Now these two cancels. So what will we get? 2 Fca square plus Fca square is 3 Fca square. Okay. Now what is Fc? Fc is equal to root of this root 3 Fca, or it is equal to root 3 times. What is Fca? Having a value K into Q square by L square. This is equation number 3. These are the forces on the individual charges. Fa, force on charge A, this one. Force on charge B, this one. Force on charge C, this is the force. Now what is the resultant direction? Since it is both having equal magnitude, both the vectors, resultant will be directed vertically downwards. Okay, this is the direction of Fc. Fc is acting vertically downwards. Okay. What will be the resultant of these two forces, Fa and Fb? We can see that where we can show that this force and this force, okay, they will make a resultant in the vertical upward direction. So when you add sum up these three forces, we can show that it will be 0, because when you add Fa and Fb, when you bring these vectors here, suppose I just bring the vector here, this vector I bring to this point, this will be the direction Fa. This vector also I will just bring to common origin. This will be equal to Fb. Okay, this is Fb and this is Fa. This will be the resultant of these two vectors. Both will be equal and opposite. We can prove that the sum will be equal to 0. Okay, thank you.